All right. So here is an update on the space game development that I've been doing. So previously, I pointed out that I was using PID controllers to handle the movement of a ship. Um, I've since finished that and then optimized on it. I'm still using PID controllers to decide the uh, angular velocity needed to meet the mouse target rotation. And I'm also using it for linear velocity relative to the ship based off of D-pad input. However, I was using 3 PIDs per individual thruster to try and achieve those accelerations. And that was not working out great because it was always firing all the thrusters maximum when it fired them at all. So I threw out a little math problem uh, and I figured it could be done in matrices as suggested by Prince Bastion. And sure enough, a somebody who is a math person answered and was able to get a formula from them that looks kind of like this right here. So essentially, I have an output that includes all of the thruster values that I want, given an input that is the acceleration, angular x and y for each column is a thruster that I want. And with a target of either all zeros and ones or all ones and 100 to minimize or maximize the energy. I want to minimize it, so all ones and 100. Essentially, some math wizardry, but as long as you request uh, thrusts that the system can output, then it gives you the pretty like 95, 98% most optimal answer for that. It actually does a bunch of iterations trying to get closer to the best answer, this algorithm, which is called linear optimization programming. So there was a numeric JS library that does statistical math things, and it had solve LP method that I was able to plug this into after discussing with the math person, Christian. So now you can see that the ship handles quite well. Since that worked, I also added zooming in and out and scrolling. I've also added some little dummy objects so that there's something to move relative to. And once a thing goes off the screen, you can see there's a little caret to tell you where relative to yourself it is in space. You can also see there's a white box around the general size of the object, and that's a bounding box that I'm using to detect collisions with. I just implemented this code today, so it's supposed to be an axis aligned bounding box, but currently it is not, and it's really buggy and it's not picking up all of the children objects and creating a union of the largest area circumference around it. But it's enough that I can now fire rockets. So you can see there's this little part in here that looks like an arrow. That's a new spaceship part that I added called a missile. Right now, there's no differentiation between a missile and a missile launcher, which I'll fix later. But if you press 1, that happens. Boom, 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 boom. Yay, that looks awesome. So, you can see it's doing dumb stuff like trying to detect the point within the rectangle instead of testing the entire stepped path of the projectile. So if a projectile fires fast enough, it will pierce all the way through an object, which is not optimal. But I'm just doing as little work as I can for the biggest bang. So what I got this weekend, eventually I'll add the ability to actually destroy parts. I'll make the bounding boxes actually access aligned and include all of the children objects. And then when I do collision of the projectile with the object, I'll detect not only that it hit the object, but which child part inside of it was hit so that I can damage individual parts and do breakaway, etc., etc. So yeah, for now, that's it. Do, do, do.